G'day champions, thank you for joining me for our next lesson in the measurement topic. Before we get started, here is today's riddle. So a raw egg was dropped from a 10-meter height onto concrete, but it didn't crack. How is this possible? If you have any thoughts, as always, chuck them in the comments. Okay, here are some flashback questions to warm us up from what we're looking at in the last couple of lessons. For the first question, I want you to find the area of this triangle. Part B, I want to see if you can draw a rectangle that's got an area of 24 and a perimeter of 20. Okay, so there should be one rectangle that fits with both of those. And then part C, I want you to think of 6 different types of quadrilaterals. So a quadrilateral is a 4-sided shape. So there are actually 6 different quadrilaterals. If you can name them all, I'll be very impressed. All right, pause the video. Have you got these 3 questions for me? Okay, so for the triangle, we're using our formula from the last lesson, which is the base multiplied by the height. And then if you halve your answer, you get the triangle's area. Okay, so we normally just write that as half times base times height. So half times 5 times 8. 5 times 8 is 40, so half of that is 20. So there is your area. Don't forget your centimeters squared for your units. Okay, so for the rectangle, well done if you got a rectangle that looks like this, with a length of 6 and a height of 4. Okay, base times height is 6 times 4 is 24, and the perimeter is 6 plus 4 plus 6 plus 4, which is 20. Okay, so that's the only rectangle that works for both of these measurements. And for the quadrilaterals, okay, so all 6 of them are, obviously square is an obvious one, rectangle pretty obvious. We also have rhombus and parallelogram, and we have trapezium and kite. Now, if you haven't heard of any of those quadrilaterals, don't worry, because we're going through all of those today as we find the area of quadrilaterals. So we already looked at rectangle and square in the last video. I'm going to show you how to find the area of the other 4. Okay. Starting off with an easy one, we're looking at the area of a parallelogram. Okay, so a parallelogram is really just a rectangle that's sort of slanting a bit. We still have 2 pairs of equal sides, and for this we're going to consider the base and the height. Okay, so the base length and the perpendicular height. That's why we've got a little 90 degrees there. Now what I'm going to do is I'm going to cut off this little triangular piece on the end. Okay, I'm just going to slice that off. I'm going to move it over here, and what do you have? You have a rectangle. And how do you find the area of a rectangle? Well, you do base times height. So logically a parallelogram must be the same thing. Okay, because you can just rearrange it to make it look like a rectangle. So parallelogram's area is just its base times the height. Okay, it's a neat little trick and it's worth remembering. So if you're taking notes, I recommend you draw up a little parallelogram and write down area is equal to base times height, so you can use it for the exercise today. All right, and for our next shape, we are looking at the trapezium, which is just a fancy word for a quadrilateral where 2 of the sides are parallel. Okay, so these 2 sides are flat, they're going in the same direction. These 2 sides can be going whatever way they want, I guess. We're going to call these 2 flat parallel sides, we're going to call them A and B, and we're going to call how far apart they are H for height. Okay, this one's a little tricky. What we're going to do is we're going to slice this trapezium in half, like this. Okay, and now I'm going to take this top half, I'm going to flip it upside down and put it down here to make this. Okay, why have I done that? Well, because what I've made here is actually a parallelogram. Can you see that? I've got 2 parallel sides here, and I've got 2 parallel sides here. Okay, so if you're clever, you can cut and paste and rearrange any trapezium to just be a parallelogram. And as we just saw, the area of a parallelogram is just the base times the height. Well, now our base is, well, this is A and this is B, so our base is A plus B, and our height was half of what we started with. Okay, we started with H, we cut it in half, so now this parallelogram's height would be half H. Okay, so we multiply those 2 together and we get this. Okay, we got half the height multiplied with A plus B. Okay, so very useful formula. Once again, I recommend you draw up a quick trapezium and write this formula down so you can use it later, but it's half times the height times the 2 parallel sides plus together. All right, and for the last bit, we have a rhombus and a kite. So similar to how a parallelogram is a bit of a leaning rectangle, a rhombus is a leaning square. Okay, so you've got 4 equal sides. And a kite is where you have two pairs of equal sides, but none of them parallel. Okay, so it looks like a kite. To find the area of these two guys, we just need what's called the diagonal length. So diagonals are lines that join corners or vertices. So we're going to call this diagonal here x and this one y. Same thing over here. Okay. The neat trick of finding the area of these two shapes is all you have to do is do half times x times y. Okay, so you just multiply the two diagonals and then you halve your answer. The reason for this is because we're basically doing the area of a triangle twice. It's kind of confusing, but that's the basic concept. We're basically just doing triangles, okay? And here is the formula. Okay, so hopefully you've written that down and we can apply this to some questions. We're going to start off with some straightforward ones. We're going to find the area of these three shapes. So if you think you know what you're doing and you've got those formulas written down, you can pause the video and have a go yourself first before I jump in and ruin it for you. Here I go. Okay. So for our first one, we are looking at a trapezium, okay? I know that because we've got the two parallel sides. So I'm going to write down my formula. Area equals half the height multiplied with the two flat sides plus together. So I'm just going to call these A plus B. All right, let's sub in our value. So our height we can see is the 7. It's how far apart the two parallel sides are. So I've got 7 divided by 2 multiplied with 6 plus 10. Okay, if I put that through a calculator, so 3.5 lots of 16 is going to be 56. So we've got 56. Our units were meters, so I'm just going to write meters squared because we've got an area, of course. Okay, so if you know the formula, it's actually very straightforward. You just got to substitute in. So you just got to identify the shape, use the right formula, and yeah, Bob's your uncle. All right, next one. Just going to do this one in blue. It's just a parallelogram. Okay, very straightforward. All you need to be doing is just the area is the base multiplied with the height. Okay, so all we need to do is 50 times 12. Whoopsie. 50 times 12. All right, so let's think. 5 12s would be 60. So 50 12s is just an extra 0. So 600. Once again, we got centimeters. So I'm just going to do centimeters squared. Cool. Okay, and for the last one on this slide, we have what looks like a rhombus to me. Okay, it's not a diamond. No such thing as diamonds in mathematics, especially on my salary. So we got area is equal to half times x times y. Okay, x and y. Ooh, that looks weird. X and y are your two diagonals, which in this case are just the 3 and the 8. All right, so we just got to do area is half times 3 times 8 times 8. There you go. All right, 3 8s are 24. Half of that is 12. So we got an answer of 12. We're going to do kilometers squared, square kilometers. There you go. Super, super simple. Let's have a go at some ones that are maybe not so simple. Okay, so we've got a couple of more challenging questions here. We're trying to find the purple areas. So not the whole shape, just the purple part of the shape. Okay, so how are we going to do that? Well, for this first one, what we're going to do is we're going to subtract areas. Okay, so we're going to find the area of the big outside shape, which would be the whole thing inside. And then if we can find the area of this white shape inside, and if we take it away, that logically should leave us with the purple part. Okay, so what are these shapes? What do you think? What type of quadrilateral? They are actually trapeziums, okay? Because again, they've got two parallel sides and the other two sides are not parallel. Okay, so to find the area of these, we're going to use the area for a trapezium formula, okay? Again, it's half the height multiplied with the flat sides plus together. We're going to do this twice. We're going to do the big one, and then we'll take away the little white one to leave us with the purple part. So we're going to do this. Okay, for the big one, we've got the height of 9, A and B are 17 and 26, like this. And then we're subtracting the small one, which has a height of 4, and the two flat sides are 6 and 13. All right, so we can just put this straight through our calculator. If it gives you a fraction, you can press the SD button and you'll get a better answer for this topic, which is a decimal that looks like this, 155.5 square meters. So well done if you got that by yourself. For the next one, we're going to do similar logic. If we can find the area of the outside shape and take away the inside shape, we'll be all done. Bob's your uncle. So how are we going to do that? What is the outside shape? Don't overthink this one. It's just a rectangle, just the length times the breadth, or however you want to think of it. The inside shape is not a diamond. I repeat, not a diamond. It is a rhombus, okay? And the formula we just looked at is you multiply the two diagonals, which in this case are 14 and 18.3 again. We multiply those and we halve it. All right, so here's our formula. We're doing the rectangle, the outside rectangle, take away the inside rhombus, okay? Where length and breadth are 14.3, 18.3, and same thing for the rhombus. Those are the diagonals, coincidentally. So here's our calculation. We need to put through our calculator. Be careful with your brackets and your times and everything. But if you get it right, you should have gotten 130.845 square meters. All right, cool. So the focus of this lesson is being able to A, recognize what type of quadrilateral you're looking at, and B, apply the correct formula. Okay, so I've put up a worksheet on Google Classroom for you guys to get more practice. And if you need some help, as always, just let me know. Thanks so much for watching. I hope you either learned or remembered something, and I'll see you later on.